taking over here. Today we're going to learn how to combine everything. Hooray! So ideally we learned the first day that F equals ma. But then at the time we just learned that F stood for force and force was in newtons and everything was super easy. And then all of a sudden we started learning other stuff yesterday, and like some of you were asking, there's a lot of F's. There's like F caused by weight, and then there's friction force, and there's normal force, and there's all kinds of weird forces, and how do I tell them all apart? It's not that bad though. Really the one that's given in a problem most of the time is the applied force, because that's the one that's easy to measure. How hard are you pushing a foot?
So we have to bring this one side.
No, I think that was just so your mouth can see everybody's all at once. So we learned about FF and FN and W and FA all had the unit newtons. But what do you get when we add up everything? What we get when we add up everything is called the net force, and the net force is the sum of everything after they have combined it. So after all the forces are done fighting, we're left with the net force. So some people think, wow, that's going to be really hard. No, it's going to be really simple. But the Fnet is the F in F equals ma, so it's the net force that causes the acceleration, not the applied force, but the net force, what's left over from there. So we need to rewrite Newton's third EWSH as Fnet equals Fa, because it's that net force. It's what it is after everybody's done fighting. So if somebody's pulling on me, and they're pulling me to the right with 100 newtons, and somebody else is pulling me to the left with 50 newtons, who's going to win? This guy. By how much? By 50 newtons. In what direction? That way. You just figured out net force. Was that hard? No, it's really easy. Let's try it again. Here's Bob. Bob weighs 16 pounds. How hard am I pushing up right now?
More than 16 pounds.
No, I'm pushing up with 16 pounds. He's not moving. So he's pushing down with 16 and I'm pushing up with 16. If I want Bob to move, I need to push with
17.
More than 16. So I push with more than 16, I accelerate him upward. So if I pushed with like 20 up, then I had a net force of 4 going up. Now, since Bob is my friend, I don't want him to fall, and so if I slowly lower him down, how hard was that pushing then?
16.
Less than 16, because he was winning that fight, and so we were going down. So if I was pushing up with like 15 and a half, then my net force would be a half going down, because he was winning that time. Does this make any sense? This is all net force is. All we're saying is what forces are actually fighting in the motion, who's winning by how much. We can totally handle that, right? Aren't you glad I didn't just drop Bob on top? That would hurt. Well, it wouldn't hurt you much. Okay, so what are our net force formulas? Well, it kind of depends on which direction we're traveling. So if we're going horizontally, usually our applied force is fighting. Thanks. So friction. If I'm going sideways, if I'm dragging you across the floor, then I'm pulling this way and friction's pulling the other way. They're fighting. If I'm going up and down like I was with Bob, then my applied force was fighting his weight. His mass causes a weight. The weight is the force. So a force fights another force. A force doesn't fight the mass. So the force is fighting the other force, which in this case is weight. So friction and weight are usually battling the FA, but could they ever work together with it?
Yes, there's just that. Yes.
If something is flying toward me, then friction's trying to slow it down. And if I start shoving on it to try and slow it down, then me and friction are now working together. Or if I took Bob and I body slammed him down to the table, then both his weight is pushing down and I would be pushing down, so then we would be working together. But most of the time when we're doing this, I'm trying to toss him up in the air. His weight stealing some of that force. What's left over actually is causing the acceleration. Is that starting to make sense? Yeah. So our formulas are going to look like this. We're going to have one for side to side, and we're going to have one for up and down, and they're going to look all prettiness like that. Isn't that lovely? So you have that written down on your little piece of paper. Now, what's this little thing mean? Plus or minus. How do I know if it's plus or if it's minus? You have to think. So again, it's not hard thinking, but you do just stop and think. And some of you were like, yeah, when I had Bob way up here, and I said I'm lowering him down. Some of you were like, oh yeah, so now you're pushing down. No, I was still pushing up. It's just I'm not pushing up as hard as Bob is, and so he's winning. If I was pushing down, then I'm body slamming him, but I wouldn't do that to my friend. So, he's my only friend. So, yeah, you just have to think, are these working together or are these working against each other? Most of the time they're working against each other, so most of the time it's the minus. So, that's what you got to do. Ricky's shoving a 41.8 kilogram box with a mu of 0.378 across the floor with a 275 Newton force. What is the acceleration rate on the box? Well, again, we know something. The first number we see is 41.8 kilograms, and kilograms, of course, has to be a mass. And then we have 0.378, and if you don't see any unit, you say, haha, the only thing we know without a unit is the mu. And of course, our last one is a 275 Newton force, so newtons, of course, has to always be a force. And which force would this be? That's the force that Ricky is shoving with, so that is the applied force. Now, many of you at this part are saying to yourself, wow, this is going to be totally easy. I'm just going to say, hey, A equals F over M, and I'm just going to take this F and divide by this M, and you would be sadly wrong. Okay, so that is what we want. We do want to use A equals F over M, but the F here is which F? It's the net force. It's what's left over after everybody's done fighting. So it's not the applied force, it's the net force. So make sure you don't just plug in that simple. So we're going to say, okay, A is equal to F net over M. Do I know the F net? No. Do I know the M? Yes. So that's going to be 41.8, and I don't know the F net. So do I cry? No, you don't cry. You say, if I don't know the F net, do I have a formula for F net? And you say, yes, I just handed you two of them a second ago. Which one am I going to want to use? How do I know I want to use the one going side to side? Because he's shoving the box across the floor. That sounds like side to side to me. So that's how you decide. It's not very hard. So the F net one again, that's going to be my applied force plus or minus my friction force. So then I say, hey, what's my applied force? That's going to be 275. And then I'm going to plus or minus my friction. Uh-oh. I don't have a friction force. So do I cry? No, I don't cry. I don't give up. I say I don't know the friction force, but do I have a formula to calculate friction force? And of course, yesterday you practiced knowing that the friction force is mu times E. You had two versions. Well, I have this time, so I want to use the mu mg version because I have the m. So now if I only knew what mu was, I do. So that's 0.378, and I know the m. That's going to be 41.8. And now, if only I knew what g was, I do know what g is. So g is going to be, now did I run out of things that I don't know?
Yes.
Yeah, so now all I got to do is solve my way back up to the top. This is really easy, right? Every time I run out of something that I don't know, I find a formula for that one. Yes, sir.
Is it negative?
Again, if I'm in the side to side, we kind of ignore the negative on 9.81 because the negative means down, and down doesn't have meaning when I'm going side to side. So if I take my 0.378 times 41.8 times 9.81, lots of 8. I get 155 newtons. Now, this goes where I was missing it right here. So now I have to do my thinking. So now I have to say, okay, are these working together or are they fighting each other?
They're fighting.
Well, again, yeah, if Ricky's trying to shove the box across the floor, then he's trying to make it go to the right. Friction's trying to make it go to the left. Friction's always fighting us as far as that goes. Ricky's not trying to slow it down. He's trying to speed it up. Friction's always trying to slow it down. So, yeah, so, well, that wasn't nice. There's my back button. Okay, so after figuring that out, that of course has to be a minus. So if I take 275 minus 155, that leaves me how much left over? Hey, there's 120 left. So 120 newtons left. And what is the leftover force going to do?
It's gonna go on top.
It's going to cause the acceleration. So that's what was missing up here. So now we're going to take the 120 newtons and divide by the 41.8. And there we're going to get 2.87. Start the right meters per second squared would be a much better unit for acceleration. And of course I rounded it off to 3 numbers because that's what this one and this one and this one all have. Don't you just feel smarter after a problem like that?
Yes.
Aren't you happy that you took physics with me instead of some other wuss teacher that would have just taught you F equals MA and stopped there? Right. Yeah. Yeah. I like to think. Okay. So moving on, our next problem. Tony throws Sam up in the air with a big force. She has a 38.6 kilogram mass that accelerates at 14.8 meters per second squared. How hard was he shoving? So again, I see our first number is kilograms. Kilograms has to be mass. And then we see a meters per second squared, and that has to be acceleration. And then we're looking for how hard did he shove, so we're looking for which force?
Applied size.
If it's the force he's shoving with, then that's the applied force. So again, we have to start thinking, I'm looking for applied force. Well, where does applied force show up in formulas? It only shows up in today's formula. We have 2 formulas today, but we found out that Fnet equals Fa plus or minus, and there were 2 different versions on what it was plus or minusing. How do I know which one to use? He's throwing her up in the air, so clearly I want the up and down one, so that's going to be W. Now, if I'm looking for this one, that means I probably don't know the other 2. I don't know W and I don't know Fnet. I know Fa, I know M. So again, do I panic, curl into a fetal position and cry? Or do I say, hey, do I have a formula for Fnet? And you say, sure, I know that Fnet, I can write. I know that Fnet equals MA. And that would work out great if only I knew M and A. I do know M and A. that gives me 572 over here. And then I say, this would work out great if only I knew W. But of course I know that W equals mg. We learned that yesterday. And that would work out great if I knew the m was 38.6 and I knew the g was
Negative 9.
yeah. And so here I get 379. Now, when I plug that in over here, I'm going to write it as a positive number. I'm going to write it as a positive number because some of you are going to freak out on some other things. Now, watch and you'll see why I wrote it as a positive number. I want you to think rather than just memorize. And the thinking comes in again here on the plus minus part. So when you plug into the Fnet, always leave everything positive. We're just looking for what's happening here. Now, Tony's trying to throw Sam what direction? He's trying to throw up. So his applied force here, that's not a very good error to have here. The applied force is pushing up, and the weight, of course, can only push down. So are these two fighting each other or working together? They're fighting each other. So do I want a plus or do I want a minus? I want a minus. So now I'm going to stick that minus in there. And here's where it's nice. Now, some of you could have said, well, yeah, we're adding that negative, and the negative's already telling me what direction you're going. But then others of you would have said, well, do I subtract the negative and end up adding it? And it gets confusing. So it's better to avoid the confusion if once you plug it in here, it's always positive, and you actually think, are they working together or are they fighting? That way you won't mess up on directions like that. Now, to find FA, of course, FA is connected to 379 with a minus, so the 379 goes to the other side with a plus, so we're going to end up with 572 plus 3, stop it, 79 equals FA. That's going to be what? 9. So what that's saying is Tony has to shove up with 951 newtons. 379 of that got stolen away by her weight, leaving us 572 extra that could actually cause the acceleration as he was throwing her. Yes, sir.
What's the force with the capital N?
The force with the capital N is that normal force. And that was, again, on a horizontal surface, it's just equal to the weight of what's on top, shoving down, and the table shoving back up, or the floor shoving back up, or whatever you're shoving. So that's pretty much all you have to do. Things to remember. The normal force and the net force look similar. You can tell them apart though, because this one says net, and that one just says So that does confuse a couple people, but it's not that hard. The normal force will be given to you a lot of times as a weight of something. Why not just spazzing out on me? Okay, the applied force is almost always the force that's given, or it's the force that's being solved for. And it's usually also the biggest force because stuff is being stolen away from it often. So that's a good one to look for in case of that. But again, you can think your way through it. If you see a force, you think, is this the force that they're shoving with? Does this make sense? That's the applied force. If it's a force that's given right before you have a noun, like a 129 Newton box or 150 Newton person, that's going to be their weight. And so that would also be the normal force. And again, most of the time the forces are subtracting from each other, but if they're both opposing the motion horizontally, or if they're both going down vertically, then they're both going to be negative, they're both going to add together, and they'll make the Fnet bigger than the Fa. Usually the Fnet is smaller than And that's it. So for homework, I want you to do problem C, of course. Now you'll notice when you look at problem C, is that, what do we have? How many problems do we have? 13, and they're all math problems. Now normally I give you 5 or 6 math problems. Why am I giving you more now?
Because more people have trouble.
This problem I have found over the years is that people need a little extra practice on this section. And so I don't give you extra practice to torture you, and you know what you are capable of. So if you whip through like the first 6 of them and you're just whipping through them and you totally got it, go ahead, stop, jump down to number 13. If you can handle number 13, you got it made. On the other hand, if you're still struggling, then take the extra time and practice some more and make sure that you can get them down. So I give you extra practice on this one because I found over the years that people need extra practice. But if you can do number 13 correctly, then you totally understand this. Okay? That's fun.